All right. So the first of the differentiation rules is d dx of the function c. The function c is a constant function. It's just, it'd be like if I graphed it, it would just be a horizontal line. So the derivative of a constant is equal to 0. So the derivative of a constant is equal to 0. And then this is the power rule. The derivative with respect to x of x to the n is equal to n x to the n minus 1. And as a matter of fact, we've learned that in the first section here, they just state that this is the case where n is a positive integer, but in fact, we've learned that it works if n is a negative number, if n is a fraction. So there it is. And that's the power rule. So a couple of examples here. Move it right off the page. There it goes. All right, so we have d dx of x to the fifth. I should do one with a constant too. Actually, we are going to when we do our polynomial. The d dx of x to the fifth then have as its derivative 5x to the 5 minus 1, or 5x to the 4. And we learned that you can rewrite 1 over square root of x as something like d dx of x to the negative 1/2 power. And then go ahead and apply the rule. So d dx of x to the negative 1/2, which is equal to negative 1/2 x to the negative 3/2, yeah. So you got to go negative 1, negative 1/2 minus 1, negative 1/2 minus 1, which is negative 1/2 x to the negative 3/2. And I mean, you can rewrite this. You don't have to. You actually don't have to. When it comes to the AP exam, it's okay to leave things in this form with negative power. It's not a problem. And what does become a problem is if you do rewrite it and rewrite it incorrectly, and if you have to take off points. So it's almost better sometimes to just leave it low, unless you think it'll be easier if you're going to go plug in a value or something. But if I were to rewrite this in simplified form, it would be negative 1 over 2. And remember, the root is on the bottom, so that's the square root of x to the, and then the power is on the top to the third power. There it is. 1 over, or negative 1 over 2 square root of x to the third. So that's the power rule. And then if I were to add one more example with that first rule, we have d dx of, say, 5 is equal to 0. And that would be the function f of x equals 5. It's just the constant function. So d dx of the constant is equal to 0. All right. Some more rules here. Derivative with respect to x of the sum of two functions. So u and v are functions. Is equal to du dx plus dv dx. So you take the derivative of each one, and then you can add them together. So derivatives work over the sum of two functions. And we've used that already. We've actually used that with the power rule and a polynomial with more than one term. Okay. And then the derivative with respect to x of u minus v is equal to du dx minus dv dx. So you could take the derivative of each function individually and then subtract them. All right, so if y equals x squared plus x minus q derivative of x plus 5, find y prime. This is going to use every rule we've seen so far. The constant rule is applied here with the 5. The power rule is applied to each of these three terms. We're going to see the sum of two functions. We're just going to take the derivative of each one and then combine them by addition. And then the difference is right here. So this has all four of these rules that we've seen in this one. And so pretty intuitive, I think, that derivatives work over addition and subtraction. So y prime, this is another way of saying dy dx. Okay, we call it y prime. Y prime would be equal to the derivative of this guy, x squared, has as its derivative 2x. And then the derivative of x is just 1. And then we might want to think of this as x to the 1/3 power. So its derivative will be minus 1/3 x to the negative 2/3 power. So subtracting 1, 1/3 minus 1 gives us that x to the negative 2/3, and then plus 0, and then we could clean it up if we want to. Leave the 0 off. 2x plus 1 minus 1 over 3 times the square root of x to the 3rd. And that's using all four of those just around those rules. Yeah.
Can you turn your computer screen?
Yeah. You guys are shifted up a bit. Or we could move the desk back around. Right, shift it up. Sorry about that. Yes, you are welcome to turn it. So it's a combination of all the rules here. We're using the power rule and the constant rule and then combining them for addition or subtraction. So our final answer here is y prime equals 2x plus 1 minus 1 over 3 times the square root of x cubed. Oops, I went backwards. You see that? Sorry. So here it's a cubed root of x squared. That's negative 2/3 power. So change that up. Sorry about that. I could do it in red. Change this up there. That's cubed root of x squared. Minus 2. But that's the type of thing on the AP exam. Like you're fine just leaving it x to the negative 2/3, and you don't have to worry about making a mistake like that. Because they're grading your calculus. Unless you bring that into the mix. All right? So there's the first four rules. We have more coming. Yeah. But so far, they're pretty intuitive. Not too bad yet. So here we go. 3 more of them here. Derivative d dx of u times v. This one's called the product rule. I might name it here. Product rule. The product rule. And I should look in your textbook. Actually, if you grab the textbook, I'm going to show you here. There's different ways. Right here. They'll have the whole list in here. So we're going to have the product rule, the quotient rule, and I think there should be a constant rule on here too. It's interesting here. They're going to wait till the next chapter to give us the chain rule. They're going to wrap up this chapter with the rules about derivatives for trig functions, and there's a bunch of them there as well. But if you turn to define 3.3, show you it's here. So they have little brown boxes here, and they have a proof of each one, which is kind of cool. pretty cool. If you look at the product rule here, it's on page 119. Oh, and they separate out the power rule into two different cases. They have rule 2 because they prove it, and they prove it for a positive integer first, and then on rule 7, over on page 121, they do the power rule for negative integer powers, and it's a separate proof for that. And then later on, they bring it in for rational powers. So we're just combining it all in one. Okay, so for the product rule, you can see the way in which they go through. You see down there on the bottom of 119. How do they go about proving the product rule? Do you see what they're doing? A lot of algebra, yeah, based on the difference quotient, right? So, and that's the approach they take there. It's kind of like, in your geometry class, when you get one theorem, like when you get a theorem, you can use that theorem to prove other theorems. You can kind of build. We did that with trig as well. Like we got the sum and difference identity and then use that to build other ones like the double angle formulas. But they do a little bit of that. Product rule, it's a mess of algebra to prove it. But it's there if you want to kind of look through it and see what's going on. But what it says here is ddx of uv is equal to u dv dx. And there's different ways to think about this and memorize it. But it's, you take the first function, u, you don't do anything with it. But you do multiply it by the derivative of the second function, so dv dx. And then it's plus, and then the second part is you take the second function, which is v, and you just write it down, and then it's times the derivative of the first function. And it turns out with the product rule, because of the summation there, and just because of the commutative property of addition, it doesn't matter which order you do that in. So what you're essentially doing is you're taking the derivative of one of the two functions times the other function just as it is, plus the derivative of the other function times the one left, just as it is. So, and it doesn't matter on the order. Now when we get the quotient rule, the order will matter because we have a subtraction sign in the formula, and you'll see that in here. But there's the product rule. It's not too bad. But it is a little bit of work, and we're going to get some practice on this hopefully today, and a little bit for homework too. That's the product rule. We'll do an example of it in just a minute. And then here we have the quotient rule below it. And the quotient rule is on the next page. And I flip over the next page, 120. And you'll see that it's very similar to the product rule, except that we've got a subtraction sign, so now the order matters. And so it's going to be, this is the way I remember it, it's the bottom times the derivative of the top. So we have v times du dx minus, so bottom, so the way I remember it is derivative of the top times the bottom is the way I remember it. So I'm starting with the derivative of the top and then working to the bottom, and that's the correct order. So derivative of the top times the bottom is the way I remember it. The way they have it written in the textbook is bottom times derivative of the top. But derivative of the top times the bottom minus, and then they have here derivative of the bottom times the top, or top times derivative of the bottom, all over the bottom squared. And so that's the quotient rule. And yeah, that's, I mean, the way I remember it is it's just derivative of the top times the bottom minus derivative of the bottom times the top all over the bottom squared. I remember it. So starting with the derivative of the top first, which I think makes sense, do the top first derivative, and then you got to multiply it by the bottom function. And minus the derivative of the bottom times the top. So it's a formula. You'll have to memorize it. You'll have it memorized because you'll be using it so much. And then the last one on here for this section is the derivative of a function that has a scalar multiple. And we've already used that one. So you can slide that scalar multiple out, which is k, and then d f of x dx. And those are the 7 rules in here. That's rule number 3, and they have the proof of it over on page 117. That one's not too bad. And then if you look at like the proof for the power rule, it's kind of fun. It involves the binomial theorem and so forth, and they're super fun. But there they are. We're going to do some examples here with these guys. All right, you're going to have some problems like this. So find the derivative of this thing. Now, there's a couple different ways you could approach this. One would be you could distribute and multiply it out, and then it would be just a matter of the power rule and then the sum or difference rule. You could do that. It's probably more efficient to go ahead and use the product rule on things like this when you have one polynomial times another, just to use the product rule. The reason we're using a product rule is that we could name or label this u and this v. So it fits into a u times v sort of format. Okay? And so just taking the product rule at face value, it says take the derivative of the first and then times the second, or they said take the first times the derivative of the second. I guess we could do that. It doesn't matter because of the plus sign. It's plus sign. So I typically do derivative first times the second plus derivative second times the first. So it's a little different from the textbook version of this. But either way is fine. You should probably, I guess, go with it as it's written up here. So take the first function, so we write y prime, is equal to the first function here. Just write it down, x squared plus 3x minus 2, and then times the derivative of the second. And the derivative of the second is going to be 6x squared minus 14x, and then plus the second part of it. We're going to just take b and copy it down just as you see it, 2x to the third minus 7x squared, and then times the derivative of the first, which is 2x plus 3. And you know what happens to the negative 2? 0, yeah. The derivative of negative 2 is 0. So you're applying, once again, the product rule, but within the product rule we have the sum and difference rule, the constant rule, the power rule, okay? And you can leave it like that. Unless for some reason they ask you to, solve for something. But you can leave it like that. And when you're doing a practice, go ahead and just leave it like that. We're just practicing the product rule, not algebra. Any questions on that one? Once again, copy down this guy right here, and then times the derivative of the other, plus copy down the other, times the derivative of the first. All right. Let's do a quotient rule example.
And leaving that in that format is okay?
Yep.
Oh.
It is. Yeah, it's kind of hard to wrap your brain around, but yes, it's actually encouraging. When you're taking the AP exam, you just don't want to spend the time on simplifying stuff like that. It's a multiple choice question. They do some kind of simplification. You'll have to match it up. But just find the derivative of, okay, so this is going to be the quotient rule. We're going to need lots of room here. I'll do this in red so it'll show up over the top of the blue here. But y prime. Okay, so looking at the formula, we're still kind of watching the formula here. It says take the derivative of the top and multiply it by the bottom. Or literally, it actually says take the bottom. This is the v. Remember, this is the u. This is the v. So take the v, which is x to the fourth minus 6x squared minus 5, and multiply it by the derivative of the top. So remember that we're thinking of this as 5x to the 1/2 power. And we're going to apply the chain rule to each piece there. So the first piece will be 6x And the second piece will be 5 times a half is 5 halves. X to then drop the power down 1. So 1 half minus 1 would give me a negative 1 half. And then minus 4, the derivative of 4 is just 0. So there's the first part of it. And we have a minus sign. And we're just going to copy down u, which is 3x to the second, plus 5 root x, minus 4, and then multiply it by all this. Move it one piece at a time. All right. All right, so we've got that, and then times the derivative of the bottom. So the derivative of the bottom would be 4x to the third minus 12x. Just barely fit all over. Get the all over part. X to the fourth minus 6x squared minus 5 squared. And that's my derivative. You can leave it like that. We do. We have the top part is the u, bottom part is the v. And there's our derivative. So it's not too bad, as long as we don't have to simplify it. That's the quotient rule. The quotient. Now you can take derivatives beyond first derivative. We call it second derivative, third derivative, etc. They have different applications in physics, at least the second and third derivatives do. You don't want to be called a third derivative. It'd be bad. You have to look it up, what third derivative means. You don't want to be a third derivative. Second derivative is okay. Don't be a third derivative. All right, y prime means first derivative. And y double prime just means second derivative, we'll abbreviate it. And then y triple prime means third derivative, and you can have a little symbol for a fourth derivative and so on. But in terms of applications, we're good through the third derivative, and we don't use beyond that too often. So first, second, and third derivatives. So you might be asked to take any of those derivatives we've done and find the derivative again. Heaven forbid it was the last one there. Something else. In that case, when you're asked to take another derivative, it might be beneficial to try and simplify before you take the derivative again. So first, second, and third derivative. Oops. Right. Then also, the other symbolism we use, I should put that on here as well. Let's add it on here. So this, remember, is dy dx. Second derivative would be d2y dx2, and then third derivative would be d3y dx3. So that's the other symbol. Using, I guess, closer to the original notation that was used, where they replaced the delta with the d. This is the dy dx, d2y dx2, and d3y dx3. So what this is asking for here is the second derivative, which you can call y double prime or d2y dx2. So first thing we're going to do is find dy dx here. And dy dx is equal to 15x squared to the fourth, 15x to the fourth. And then negative 4 times that negative sign will give me a plus, and then times 4. 20x to the negative 5. Be sure to go to the right direction. You got to subtract 1 from the negative 4, and then plus 7. So that's my dy dx. And so my d2y dx, or second derivative, d2y dx2 is equal to 60x to the third minus 100x to the negative 6th, and then the constant function 7 has as its derivative 0. So there's the second derivative. All right, we can find the fourth derivative of this polynomial function. So dy dx of this guy is going to be 7x to the 6th minus 2. And then the second derivative d2y dx2 is equal to 42x to the 5th, and the constant function is equal to 0. And then d3y dx3 is equal to 210 x to the 4th. And then finally, we have d4y dx4, the fourth derivative, is equal to 4 times 210, so 840 x to the third. So that's my fourth derivative. And you keep going until you hit a point at which the derivative is equal to 0. And it's just going to keep being 0. The derivative of constant function 0 is 0. Right? So those are the rules of differentiation. We believe the difference quotient behind is a way of finding the derivative.